Hello Year 9. So we are going to use the atomic masses and the formula masses that we've been doing over the last few days to come up with the calculation for percentage by mass. So we're finding out the percentage compositions of different compounds. So we're bringing together the two ideas that we've done in the last couple of days. But first of all, you have got the answers to the formula masses that you did on Monday. Okay, so these are how you work them out, okay, and the answers for you to check your own, okay. And then I've got a little retrieval quiz, so you need to pause the video. You won't be able to set yourself a timer, but you need to pause the video and see if you can come up with any of these answers, okay. So these are your answers to those questions. Hopefully you should have got at least the first three, okay. The other ones are a little bit more tricky, but you should have definitely got the first three. Okay, so what we're going to think about is this percentage by mass idea. So it's really useful in industrial chemistry to work out how useful substances are and even to test the purity of them. So it's thinking about the percentage composition of compounds. So we use this formula here. Now I know it looks complicated because it's all symbols and letters and it looks tricky, but it isn't, okay? The percentage of any element, right, we look up the big number, the relative atomic mass, so RAM stands for relative atomic mass, of that element, and then we multiply it by the number of atoms in the compound, okay, just like you've done before to work out the formula mass. We then divide it by the total formula mass, and to make it a percentage we multiply it by 100, okay, and I'm going to work through some examples just to make sure you understand what I mean, and then you're going to practice some. Okay, so for example, if we think about ammonia, ammonia has got the formula of NH3. Okay, so it's got 1 nitrogen and 3 hydrogens. Now, if I've looked up the big numbers in my periodic table, I know that hydrogen has got a big number of 1 and nitrogen has got a big number of 14. Now, my first job is to work out the total mass of that compound. Okay, so I do it just like I've done before. I've got 1 nitrogen atom and 3 hydrogen atoms, so that's one lot of 14 added together to 3 lots of 1, which gives me a total of 17. So the whole formula, the whole compound has got a relative formula mass of 17. Now I want to figure out how much of that is made of nitrogen. Okay, so I know that there's only 1 atom of nitrogen, so that has a atomic mass of 14. Okay, so 14 multiplied by 1 divided by the total that I've worked out previously, so 14 divided by 17, and then multiply by my 100 to get my percentage. Okay, so that gives me a percentage of 82. Now, there's 2 ways that I can think about this. Obviously, the whole of the compound has to be 100%. So if nitrogen makes up 82%, that must mean that the remaining 18% is made up from hydrogen. Okay, because it has to add up to 100%. So that's one way that I could figure it out. But I can also check that by doing the calculation. Okay, so we know 82% of ammonia is made of nitrogen. So if we want to check the hydrogen, again, we work out the total mass. So we've got 17 again, the total mass. And then this time, if I try and work out the hydrogen, it will give me the atomic mass, which is 1, multiplied by the number of atoms, so that's 3 lots of hydrogen, so 3 lots of 1, divided by my total, multiplied by 100 to get my percentage. Okay, so this time I've got 3 divided by 17, multiplied by 100, which gives me my 18%. And like we said, 82 from the nitrogen and 18 from my hydrogen add up to 100% of the ammonia. Okay, and that's all it is in terms of what you have to do. So another one here. This is looking at water. So we've added together, we've done our first step, we've found out the relative formula mass. So I've got 2 lots of 1 for hydrogen plus my 16 for oxygen, which gives me a total of 18. Okay. Now to work out the percentage of hydrogen and oxygen, the first thing we would do, let's do hydrogen first. Let's see which one comes up first. So, sorry, it's oxygen first. So I've got 16 divided by my total of 18, which will give me a decimal. And then I multiply that by 100, which will give me 89%. So it's 8.8%, but it'll obviously be a rounded up number, so it will give me 89%. Again, that tells me that 11% is going to be hydrogen, but I can check it, okay, by saying, well, I've got 2 lots of hydrogen, so that'll be 2 divided by 18, which gives me 1.1 as a decimal, multiplied by 100, which gives me 11%. Okay, so those two again add up to 100%. So that's another example. One more example I'm going to get you to do, and then you're going to do some yourself. Okay, so we've got carbon dioxide this time. So I know that carbon is 12, and I know that oxygen is 16. So when I do my relative formula mass, that will give me a total of 44. So 2 lots of oxygen, 2 lots of 16 is 32, plus my 12 gives me 44. So to work out carbon, it's the 112, okay, because there's only one atom of carbon, divided by the total, which is 44, then multiplied by 100, so that will give me 27%. To work out the oxygen, I've got 2 lots of 16, which gives me 32, divided by the total, which is 44, and then multiply by 100, which will give me 73%. Okay, again, they have to add up to 100% when the two of them are together. So carbon makes up 27% and oxygen makes up 73% of water. Okay, now you've got 2 choices on class charts. There is a straightforward one, which is some more examples of these, and then there is a tricky one. There's about 15 questions, okay, and you really will need to think about them. Hopefully some of you will have a go at it and be quite brave, okay, and I'll go through the answers tomorrow.